Hey guys, how you doing? We are going to start off today with naming hydrocarbons. So what we did last time is we got everything down with the anes, the enes, and the ines, so we know what homologous series we're in, right? Problem is, we did a little bit of naming when they were just straight. There was just like one carbon after the other. This is what we call straight chain carbons, right? You just count them, find the longest sequence, like the longest consecutive sequence of carbons. We call that a chain of carbons. And then use that for your prefix, like meth, eth, prop, but, pent, all that good stuff. And then look at the kind of bonds to see if it's ane, ene, or ine. So you could have methane, methene. You can't have methane. But you could have propane, propene, or propine. 3 different compounds, all have the same number of carbons. But now we're going to step it up just a wee little bit. Just a wee little bit. Now, for example, what happens if instead of having just a straight chain, what if there are like little branches sticking off? So you have like 5 carbons in a row with like a couple sticking off here and a couple sticking off there. That's what we call a branched chain. That's like, it's still a hydrocarbon. So it still does the same thing. It just kind of burns, and that's what we use it for. But the difference is like how it burns. Like, for example, when you go to the gas pump, you'll see like 87 octane and like 98 octane or whatever it is. It's a rating, right? And basically it tells you how well the stuff burns. It's octane, so it all has about 8 carbons. The higher octane tends to be branched a little bit better because and that way it burns a little bit faster and more efficient because it's got all the branches, and when hydrocarbons burn, it starts from the ends of the chain and sort of burns in. So the same thing with reacting. Remember yesterday with the double and triple bonds, we needed to know how close to the ends of the chains they were, because that makes them more reactive, because these things start reacting at the ends of the chain and kind of like work their way in. Do you guys understand what I'm saying? That's why we needed to have the lowest number for the double and triple bonds, so we knew how close to the ends they were, so we knew how incredibly highly reactive they were, or maybe not highly reactive. You know what I'm saying? So, if you have a hydrocarbon with 8 carbons, but it's just a straight chain, it can only burn in 2 spots, right? Like the beginning and the end. And so, it burns right in. But if it's really branched, this branch is like all over the place, each end of the branch is where it can start burning, so it burns much faster, gives you more of a pop, and it's faster and more efficient, better for your car, I suppose. And so that's really the difference between like the stuff that costs 50 cents more or less. It's like more like the branching of the carbons, like how it burns. Still same number of carbons, right? They're just all isomers. It's a word from yesterday, right? They're all isomers of each other, so they're just shaped different. One shape tends to burn better than the other. So, straight chain carbons are like entry level. Now we're going to turn it up a bit, where we have branches coming off. It does the exact same thing because it's a hydrocarbon. It basically burns. It's like, gasoline and wax and diesel fuel. It's all the same thing. We burn it. It's just carbon and chains. Or links. But just like with the homologous series, the anes, the enes, and the ines, we need to capture the structure in the name. Why? Again, structure makes the function. The function is because of the structure. So instead of having things like vinegar, which is a name that doesn't tell anybody anything about what it is or what it does. Like if you didn't know anything about anything, you'd be like, vinegar, what's that? I don't know, it's a masala dressing. Yeah, but what's the molecular shape? You have no idea, because we call it vinegar as nothing. It's silly. So IUPAC, the International Physical Association of Chemistry, I think. I don't know. It's the International Coalition of Science People came up with this method of naming so that we could capture the name of things, or the shape of things in the name. That way we know what shape they were. They know what they do. So that's enough for like the jibba jabba. We're gonna dive right in with naming branched hydrocarbons. Whoop, there we go. So this here is what we're doing today. We are going to name branched hydrocarbons. In a minute. There you go. So step 1, whenever you do these, is you have to count the longest chain of hydrocarbons, okay? Now, some people are going to make the same mistake over and over and over again, but look, it's the longest chain or the longest consecutive sequence of carbons. For example, here's one. There, 5 carbon straight chain, right? And I'm just going to skip the hydrogens just so we can look at, like, you know, the basic structure, right? So this is an example of another compound, well, another molecule. You tell me if it's the same one. See that? This one has 5 carbons. This one has 5 carbons, right? 5 carbons in a row. 1, 2, 3, 4, 5. This is the exact same molecule. See, because it's 5 carbons in a row. 1, 2, 3, 4, 5. So the reason why these two things are the exact same is because these bonds are kind of squiggly, just like a chain, right? So you can take a chain, and you can pull it straight, and there's all the links right in a row. And then you go and drop it on the ground, and all the links are like all squiggly, messed up. Same exact thing. It's still the same chain, right? So if we draw it straight across, it helps us see the structure a lot better. So that's what we tend to do. But you will often see it bent and squiggly, or you'll see it like 1, 2, 3, 4, 5, still the same molecule, right? 5 in a row. Here's how it'll be different. 1, 2, 3, 4. Now, this is kind of like the isomer thing, right? I'm going to take this last to what we call a terminal carbon. Or the terminal being like it's at the very end. See how it's attached to this carbon? I'm going to move it here to an inside carbon. You see that? I just took the carbon from over here, and I took it, and instead of having it attached to that carbon, I just attached it one in. You guys get what I'm saying? And now by doing that, let's count our consecutive or longest chain. 1, 2, 3, 4. Well, okay, let's go back the other way. 1, 2, 3, 4. 1, 2. See how it's a shorter chain, right? But it has a branch. And we are going to learn how to name something like this. Got it? Excellent. Let's move on. Straight chains. These are one continuous line with nothing attached. That's like our example 1, our example 2, our example 3. These are just straight. There's nothing coming off of them. You can draw these all straight in a row, right? And so to indicate that, we just put an N in front of the name for normal. N-pentane, meaning normal. At least that's how I remember it, N-pentane. So this, right, I drew it like this up here. So it could also be 1, 2, 3, 4, 5. It is still 5 in a row, consecutive, unbroken, one after the other carbons. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. This is simply not going to work for me right now. Give me a quick second. Oh my goodness gracious, who writes something crazy like that there? The other thing we can do is we had this one here where it was squiggly, where we went 1, 2, 3, 4, 5. Same exact thing where we're looking for each carbon one after the other. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. You guys get what I'm saying? That's what I mean by a straight chain. Consecutive carbons. They can squiggle and bend just like a chain can squiggle and bend, but we call it a chain because it's one right after the other. You with me? Of course you are. Moving right along to branched chains. Now, these are straight chains with extra carbons sticking off of them. Technology hates my guts right now. Give me a second. There. I mean, right? So it's basically like we had in that final one where we had 1, 2, 3, 4, and then here is what we call the branch. So that one right there, that's your branched chain. Okay. So what we did with the alkanes, the alkenes, the alkynes, that's how we named the straight ones, right? N-pentane, N-pentane, that one up there is N-pentane. It's all N-pentane, normal pentane. The only thing we're doing different is putting N in front of it to say that it's normal pentane. And now we're going to mix it up. Now we're going to mix it up by I should put that down over here. By adding branches or extra carbons sticking off of it. And to do that, what we're going to do is step 1, we're going to find the longest chain or the longest consecutive sequence of carbons, okay? So here we have, what, 1, 2, 3, 4 different hydrocarbons. And one of the things I like to do, again, because dyslexia, my eyeballs don't work, I can't really see things that well, things get all blah, 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 blah. So I draw circles and squares and things. It really, really helps. So what I like to do first is I will circle the longest continuous chain. This is called the root, right? We call this the root of the name, okay? And also, just so you know, we're going to build these backwards. We're going to start here and then move over this way. So it's kind of, we build it backwards and then read it forwards. So this first one, let's see. 1, 2, 3. Is that it? Well, it's 3 right in a row, right? Just like it's supposed to be a straight chain. It says right here, it says find the longest continuous chain, right? So isn't that like just 3? No, because it says continuous, right? So here is the root. This is what we call the base chain. That one has 4. You get what I'm saying? Now let's check this one. 1, 2, 3. I could go that way, or I could go 1, 2. Or 3. Yeah, or 3. So I guess it doesn't matter. I could circle across this way, or I could like use the bent that way. I could use the bent this way, whichever. I'm gonna go simple. All right, now this mess right here. All right, I have 3 across this way, right? 1, 2, 3. Or I could approach it from the left, or I could approach it from the right. Let's see which way works. 1, 2, 3, 4. All right, now I'm going to approach it from the right. 1, 2, 3, 4. Also, this looks like it's the same either way, so it doesn't matter. 4 is the longest chain that I can find. So I'm going to circle this as my 4. Right? Sweet. Now this one. Let's because remember, bent is not okay. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I guess either way doesn't matter. I'm going to choose the first way just because that's what I feel like doing. Nice. So let's go back and name them. Meth, eth, prop, bute. So the root name for this guy is going to be butane. For this one, meth, eth, prop. The root name is going to be propane. Meth, eth, prop, bute. This one will also be called butane. Right? And the root name for this fourth one, prop, is that pentane, hexane. I can't remember 7. Do you guys remember what 7 is? Hept. Totally forgot. Heptane. Okay, so those are the base names. And for this one, it looks like we might be done, but this one, and this one, there's gonna be extra. So, there. That's the root. Next, we're gonna name the branches, those things hanging off, right? So, here's the thing. The branches made of hydrocarbon, these are called alkyl groups. That looks like a vocab word. What's an alkyl group? Branches made of hydrocarbons. A hydrocarbon branch. It's called an alkyl group. And the way that we name these things is you use the regular prefix, meth, eth, prop, bute, pent, hept, hex, hept, oct, non, dec, that kind of thing, like the prefix there. But instead of ending in ein, ein, that because that means it's like the big chain, we're going to end it with ol, YL, like methyl, right? And then using the YL, using this suffix, that's how we know that it's a chain. It's like a little piece hanging off. It's not like the big base. So this one, butane. Do you see any branches? No. N for normal or no branches, whatever you want to think of it. Butane, like we're done there. This dude, I think we went like this, right? Okay, so this one has a branch. So here's how I do the branches. I don't circle the branches. I put a square on the branch. Okay, so let's go through all of these. I think I went like this. Then I went like this. Remember, circling the longest continuous sequence of carbons. And then, after I have like that root or the base name, then I put a big square around what I'm going to call my alkyl groups. You guys get what I'm saying? My alkyl groups. So this one, this alkyl group, it has one carbon, so that's meth. And since it's a branch, it ends in YL. That's it. That's how you name that branch. Now this one has one carbon, right? And it's a branch, so YL. That's how you name the branch. This one. This branch has two, meth, eth, eth. And it's a branch, ethyl. Right? So these two are methyl groups. This is an ethyl group. You see how there's no group there? So that one's done. Like that one's just done. Okay, just done. N for nothing. Okay, so let's review. First, you find the longest chain. Circle it. That's going to be your root or your base name. That goes first, right? That goes like way over here. Next, we're going to find the branches and we're going to name them. So let's name this guy all together. Right? And remember, what I like to do is I put a square and then I name them. So this is meth, eth, propane, right? And then to the left, we write methyl. Because remember, we build these things from the right over to the left, right? You get what I'm saying? This one, meth, eth, butane. So this one was butane with a methyl group. And this guy, what do we say, heptane? With an ethyl group. Ethyl heptane. Spectacular. Problem is, we need to know exactly where they are, because this carbon could be here, it could be there. This ethyl group, man, it could be there. It could be like all over the place. And where it lies will have a lot to do with how it actually reacts, right? So where these things lie, like the effect would be, for example, whether it's going to be in like the high octane expensive gasoline or the crappy cheap gasoline that everybody ends up buying anyway. So the way that we do that is the third step is we indicate the location of our alkyl group. Now here's a couple of things. What we're going to do is we're going to name the carbon. We're going to number, not name, we're going to number the carbons in our base chain. And we're going to use the lowest number possible to indicate where our branch is, to indicate which carbon the group is attached to, right? So I guess you could start naming on this side and go 1, 2, 3, 4, 5, 6. Or you could start on this side and go 1, 2, 3, 4, 5, 6. So whether we start on this end or this end, what's going to determine that is if I go this way, is my alkyl group on the lowest number possible? Or if I go this way, is it on the lowest number possible? And again, the reason why we want to do that, to have the lowest number possible, is it tells us how close it is to the end of the chain. So if it's like 3-methyl, we know that it's 3 carbons in. If it's like 2-methyl, then we know it's like right on the edge. You know, it's like way more like reactive. Okay, right? Good. So here we go. Let's get back to it. Here's this. That guy's already named. Here's my base chain of 3. Here's my base chain of 4. Here is my base chain of 7. And then I went through and put a square around my branches. That's my methyl branch. Methyl branch. Remember, prefix number of carbons, ol, YL, means that it's a branch, an alkyl branch. That's where I got the YL, right? And if I may, we're going to go ahead and I'm going to write the names here. Meth, eth, prop, but. This is N-butane. And that one's done. This is meth, eth, propane. This is methyl propane. And now I'm going to number the carbons so I can get that number there. So I can start from the left and go 1, 2, 3, or I can go from the right and call it 1, 2, 3. And for this, in either case, it's going to be 2-methyl propane. You dig? Now this guy, the prefix is, remember from last time, it was methyl propane. But now let's start numbering. Now I'm gonna do it wrong. I'm gonna call it 1, 2, 3, 4. Do you guys see how that's the incorrect method of numbering? Yeah? You see, because that makes this, my methyl group, stuck to carbon number 3, which I guess is great. But remember, we want to tell how close it is to the edge, because that's what's actually really important here. So I'm going to go back, and I'm going to do it the right way. I'm going to start from this end. I'm going to go 1, 2, 3, 4, and that gives me a smaller number. So that's how I know that that's the right way. This is 2-methyl propane. Remember, we went and got the base name first with the circles. Then we named like what it is, like what's the name of the branch, and then where it is, right? So who, what, where. Who is it? It's a propane. What's attached? Methyl. Where is it? On the number 2. Who is it? It's a propane. What's attached to it? Methyl. Where? On the number 2. This, it's a butane. That's who it is. What's attached? Nothing. Done. So let's do our final one. We call this heptane. Ethyl. That's the who. This is the what. And now for the where. And I'm going to start numbering from the left, because that's what I usually do. 1, 2, 3, 4, 5, 6, 7. The other option is if I started from this end. 1, 2, 3. Yeah, I'm going to go with that. 3-ethyl heptane. The who, the what, the where. Who? Heptane. What? Ethyl. Where? Third. Dig it? I hope you do, because that's some serious digging you got right there, bud. All right, that was easy. Who, what, where. Base, branch, where. Base, branch, where. Just make sure that you get that number is the lowest number that you can get it, whether you're, so you start numbering from the left or to the right. Right? And again, it tells us how close it is to the end of the chain, because that's where the reactions start and happen from, and it tells us whether it's going to react super fast or if it's going to be like, not so much. Moving right along, because dude, if that's it, this would be easy. I mean, that'd be easy. We're talking about nature here. There's nothing simple, clear cut. I've never come across anything in nature that was just simple and black and white and easy. What is that mess right there? What is this? Oh, I get it. All right. So if there are more than one of the same alkyl groups, we're going to indicate the number of carbon for each and use a prefix to indicate the number of groups. Oh, I know what this is. 1, 2, 3, 4, 5, 6, and 2. Okay, this is like an old thing that I used. Okay, so here's what I'm gonna do. I'm gonna draw that same compound. 1, 2, 3, 4, 5, 6, and I believe there was one here, and I believe there was one here, and I'm gonna leave the hydrogens off so it's clear. So if there's more than one of the same alkyl groups, like this, right? We have 2 methyls there. We're going to indicate the number of carbon for each and use a prefix to indicate the number of groups. Okay, so same basic method. First, I'm going to circle the group, or I'm sorry, circle the base. 1, 2, 3, 4, 5, 6. So this will be hexane. Right? And then I'm going to put a square around each of the groups. So this is going to be these are both methyl groups, right? So So I'm going to use a prefix, right, to say how many. We're like basically going to do it twice. It's called redundancy to make sure there are no mistakes. So this is going, it's not just going to be methyl. It's going to be dimethyl. In other words, there are two methyl groups, because that's what the prefix means. That means two. That means there are two methyls, right? Like who, what, but of course we have to say where. Where are these? So let's number. We can go 1, 2, 3, 4, 5, 6. So that'll be 2, 3. Or I can start on this side. 1, 2, 3, 4, 5. No, so it's going to be 2, 3 dimethyl hexane. Who, what, where. With how many, right? If there's two. So remember, if there's more than one alkyl group, we're going to use a prefix to indicate how many. But we still have to number exactly which ones. Here is another example. I'm going to move this up here so I can do this. If I had this other one, 1, 2, 3, 4, 5, 6. Now what if they're on the same carbon though? Same deal. That's my root. My root is still going to be hexane. Here are my branches. I have one methyl group, two methyl groups, so it'll be dimethyl. Right? Two methyls. Where? Well, the first methyl group is on the number 2 carbon. The second one is on the number 2 carbon. Yeah, I'm literally doubling up like that. Isn't it silly to say 2,2-dimethyl? It's like, ugh. But sure enough, because you need to be very clear. Dimethyl means there are two. Well, where are they? They are, one is on number 2, the other is on the number 2. Very clear, no guessings at this, because that's what you want to get rid of, is guessing. You don't want there to be any guessing whatsoever. That's why we say 2,2-dimethyl hexane. That's really sloppy handwriting, but I know you wouldn't expect any more, or expect anything less, I guess. So that's how we do the naming of the branches. You guys got it? Simple, right? Except for that one exception, in case there are 2 branches. Remember, prefix to tell us the number, and you have like how many, and then the number still tells us where, and you need to number each and every group. So if there are 2 groups, you should have 2 numbers, even if it's the same number, like this. That's it. That's all that there could possibly be, right? Except for when that's not it. But that's okay, because I ain't scared, neither should you be. Let's do this thing. 1, 2, 3, 4, 5, 6. Okay, we know how to name this, right? So here's how it's going to get a little bit more difficult. There's our double bond. Okay? The process is going to be exactly the same. The only difference between this molecule right here and this molecule right here is that there's a double bond, and so that's really going to change the ending of our root name and where we start counting. So, for example, here's my root. 1, 2, 3, 4, 5, 6. Hex. Ene. And where is that double bond? 1. It's in the 1 position. Okay? Just like we did before. And always, remember, you always give this to the lowest number possible. So we're starting here. For the double bond. Because we have to show where the double bond is. Now, double bonds, double and triple bonds make a compound go from, it's nice gasoline, it burns. It's beautiful. You ever burn gasoline? Burns. It's not crazy. Dude, you put double and triple bonds on there. It's much less of a burn and far more of a so we want to know where the double and triple bonds are, because that changes stuff. Same thing. Oh, same with everything else. Now let's see what I can do here. I'm going to need to take this. move it over just a little bit. Okay, so who, the what, I have one methyl group, two methyl groups. So who, the what says dimethyl. And then the where. Well, last time we started over here, but we can't because this one has a double bond. And so that double bond takes precedent, right? We did it over here in the root name. Since we started it with the root name, we got to keep going that same way. So we started here when we named the root chain. We got to start there when we make the numbers. So this is going to be, if I'm going to number the carbons, it's going to be carbon number 1, carbon number 2, carbon number 3, 4, 5, 6. So this will be 5, 5, dimethyl, 1 hexene. And remember, I chose 1 hexene because the double bond is in the number 1 bond position. This is the number 2 bond position, number 3, number 4, and then number 5 bond position. You guys with me on that one? Who, what, where, build it from right to left, read it left to right. That's easy. Right? Is that it? Oh, dude, wait, here, let me help you out. Yeah! Hey, hold on a second. Naming hydrocarbons. Naming hydrocarbons. Now, in the front of naming hydrocarbons, you have to forgive me, my copy is blue. It's got this thing, right? Like, what are these? Oh, yeah, the words. Read the words, and on the back is like, those are the things that I want you to name. So, that's all I got for you today. I hope you are getting out and enjoying a little bit of the sunshine, because, man, it is gorgeous, and we're getting close. So, yeah. Have a great day, guys.